Hi, welcome everyone to the video lecture series on computer organization and ARM microcontroller. In this video, I'll be talking about how the communication takes place between the processor and memory. So let's begin. The figure is showing how the memory and processor will be connected using the different types of registers and the control unit and ALU unit. As discussed in the previous video, the processor is a combination of the control unit and the arithmetic logic unit. In addition to the ALU and the control circuitry, the processor will contain the different types of registers which are used for the different types of operations. So as we can see from the diagram, it is having the MAR, which is the memory address register, and MDR is the memory data register, PC is program counter, IR is instruction register, and the different types of general purpose registers which are used to hold the data temporarily, represented by R0 to Rn-1. So let's discuss in detail about each register, what is the operation of each register in order to communicate with the memory. So let's start with the instruction register, which is shown as IR. So the instruction register will hold the instruction which is currently being executed, and its output will be available for the control circuits in order to generate the timing signals, and also the control the various operations in order to execute an instruction. Next is a program counter. So the program counter is a specialized register which will keep the track of execution of a program, and it will contain the memory address of the next instruction which is being fetched and executed. Next, we have, other than the instruction register and program counter, we have the n general purpose registers, so which are represented as R0 to Rn-1. So these registers will be capable of holding the data temporarily when the operation is performed inside the ALU. It can be retained in the processor or the data can be transferred to the memory. And the other registers, which are MAR, that is the memory address register, and the MDR, which is called as memory data register, this is used for the communication with the memory. So what is the operation of MAR? The MAR will hold the address of the location which is to be accessed, and the MDR will contain the data to be written which is to be read, that is out of the addressed location. Next is, what are the different steps that are required in order to start the communication between the processor and the memory. So the first step is, in order to start a communication, the program should be inside the memory, that is through the input devices. Then the execution of the program will be starting when the program counter is set to the first instruction of the program. That is, the program counter is responsible for holding or fetching or executing the instruction which is to be executed next. And next, the contents of the program counter will be transferred to the memory address register in order to generate a read control signal which will be sent to the memory. After some time, that is when the access will be required from the memory, after a time elapse of the memory, the address of the word will be read out of the memory and it will be loaded into the memory data register, which is MDR. Next, the contents of the memory data register will be transferred to the instruction register, and the instruction will be ready to be decoded and executed. So if the instruction involves, that is, the operation by a ALU, then it is necessary that in order to perform the operation, the operands have to be brought into the ALU. Then, in order to get the operands to the ALU, it has to fetch the operand from the memory, that is by sending its address to the memory data register, and it has to initiate the read cycle. Next, when the operand has been read from the memory, that is to the MDR, it will be transferred from the MDR to the arithmetic logic unit. That is, this may require repeated cycles. That is, it may require 1 or 2 such repeated cycles where the ALU can perform the desired operation. If the result of this operation has to be stored in the memory, the result will be sent to the memory data register, and address of the location where the result is stored will be sent to the MAR, and the write cycle will be initiated. The last is the contents of the PC will be incremented so that the PC will point to the next instruction that is being executed. Thank you so much for watching this video. Please do watch the upcoming videos also.